So good morning, afternoon and evening to everyone around the world, and welcome to Design 231 Change Management. We've got 4 fantastic presentations displaying research that is pushing our knowledge and understanding of the topic of change management. So today we've got the first one is by Raquel, titled Data-Based Method for the Implementation Planning of Engineering Changes in the Automotive Industry, rated a reviewer's favourite, and then followed by Moritz, who's got the evaluation of engineering changes based on variations from the model of PGE, product generation engineering, in an automotive wiring harness. This is then followed by the third one is the identification of property change impacts based on requirements-oriented multi-criteria decision models, another reviewer's favourite by Dennis. We will then round off with a concept of multi-agent system for optimized and automated engineering change implementations by Ognjen. So the way we're going to run this is that we're going to have those 4 presentations all roll on from one another. Please feel free to put your questions into the chat. Mark it with like presentation 1, 2, or 3, or 4, so I can map those questions along. And then we'll open up for a general discussion where we'll probably start going through each of the papers individually and maybe open up to more general discussion. We'll see where the time takes us. So without further ado, please, Philip, if you'd like to press the play.
Data-based method for the implementation planning of engineering changes in the automotive industry. An engineering change can be defined as an alteration made to parts that have already been released during the product design process. The automotive industry is experiencing both an increase in the number of engineering changes as well as in the complexity and costs. The focus of this paper is the implementation phase of changes, where we can identify different strategies depending on when to implement a change. These strategies are, for example, to implement as soon as possible, to implement on a predefined date, or to implement when the old parts in the inventory are used up. The main research question that this paper answers is, when should an engineering change be implemented in order to increase effectiveness and efficiency and maximize the overall profit of the company? In order to answer this question, a method has been developed. The objective is to determine the optimal implementation date for each engineering change, and the method consists of 2 main steps. In the first step, the characterization of engineering changes, the input is an engineering change with certain attributes, and the output is an implementation strategy. In some cases, the recommendation could be to implement as soon as possible, for example, if it is a topic related to safety, or on a predefined date, for example, if the change has to comply with a new law that starts on a specific date. For these 2 cases, the method would end here, as we already have a date for the implementation. However, for all other cases, they would be candidates for the optimization strategy, where making use of several KPIs, a cost calculation is carried out, and an optimal implementation date is obtained as an output. For the characterization of changes, 6 relevant change attributes have been determined through 9 expert interviews. Based on combinations of these 6 attributes, 12 change categories have been determined. Each of these categories has been assigned to an implementation strategy. For example, a change which takes place during the series production, which is urgent, and whose reason is a security-relevant quality issue, would be assigned to category 1, security issues, and an implementation as soon as possible would be suggested. For those categories of changes that follow the optimization strategy, the KPIs that play a role in the optimization need to be defined. The relevant KPIs have been seeked in terms of time, cost, and quality. To optimize the time variable means to implement as soon as possible, and the representative KPI is the throughput time. To optimize the cost variable means to implement as cheap as possible, and the relevant KPIs found in the expert interviews and the literature research are the scrapping costs, product cost reductions, warranty costs, and rework costs. Each of these KPIs has been represented graphically as a function of time. As an example, we can see the representation of the warranty costs, which grows with time, since for each day where we could have implemented a change and didn't do it, more and more cars are produced with the defect, and this will be translated into higher warranty costs. Finally, to optimize the quality means to respect the batch implementation of changes. The batch implementation consists of the accumulation of changes and the implementation of all of them together as a batch on specific batch implementation dates. To measure this, there is a KPI named batch adherence, which is a binary KPI which has a value of 1 when changes are implemented on a predefined batch implementation date and 0 otherwise. This KPI is strongly related to the complexity costs KPI, since when we implement outside a batch, complexity costs appear, and these can be avoided when we implement within a batch. Once we have defined our relevant KPIs, we can proceed to the formulation of the optimization model. First of all, the KPIs that have to be considered in the model depend on the change category. As an example, we can see how a change that belongs to the category internal quality issue with a medium client's perception of the error has to consider the KPIs scrapping costs, rework costs, throughput time, and complexity costs. These KPIs are represented graphically on the right. We can also see that a time window is defined between the earliest and latest implementation dates. The earliest implementation date has to be defined by the user, whereas the maximum admissible throughput time will give us the latest possible implementation date. The decision variable is the time variable, since we want to know when to implement a certain change. And the objective function are the total costs, which are the sum of all other costs. As we want to know when the total costs are minimum, the date in which this happens will result in the optimal implementation date, which is the result of the method. As a summary, change attributes, categories, and strategies have been defined, the relevant time, cost, and quality KPIs determined, and with this, an optimization model has been formulated and tested at an automotive OEM. Two main aspects have been identified as limitations of the method, which can also be seen as future research opportunities. The first one is the data integration from the supplier network, such as the number of days needed for the transport of new parts, which would allow to quantitatively calculate the earliest possible implementation date, which currently needs to be estimated by the user. The second field would be a study of complexity costs to identify what types of changes or company structures typically lead to higher complexity costs, which would also allow to quantitatively better estimate these.
Hello, my name is Moritz Altner and I'm very happy to present to you the paper with the title Evaluation of Engineering Changes based on Variations from the Model of PGE Product Generation Engineering in an Automotive Wiring Harness. And I would like to start this presentation with the introduction of the most important concepts. In the picture on the left-hand side, you can see the wiring harness depicted in blue. It links all electric and electronic components in a vehicle and supplies them with energy and information. It weighs up to 50 kilograms and has a combined length of up to 5 kilometers. Due to all the functions, configuration, and requirements, one type series can have over 50 unique variants. On the bottom right, you see a wiring harness from the door, which is a part of the complete harness and used to analyze the engineering changes in this research. Engineering changes are all changes to release technical artifacts. And engineers spend 80% of their time on these engineering changes, which is 4 times higher than in other fields. This is due to the complexity of the product, the number of changes, but also the effort connected to evaluating changes. In order to deal with this problem, we would like to introduce the PGE product generation engineering. The PGE is based on the principle that all products are developed in generations. When a new product is developed, it always refers to reference systems. These reference systems are altered in one of three ways, either by a carryover variation, that means the reference system is taken and implemented in the new product, by an attribute variation, that means the reference system is taken, a certain attribute is changed, and then it's implemented, or by a principle variation, where the reference system is taken, the working principle is changed, and then it's implemented. Using reference systems and the types of variation, we are able to describe the whole development process. Research has shown that these variation types are closely linked to risk and effort of a change. This is why we wanted to investigate how the PGE can be used to improve the evaluation of engineering changes. So first, the first research question is, which types of engineering changes actually arise in a development project? Second of all, we want to see to which extent the variations are able to predict the risk and effort of an engineering change. Third, we want to look at additional factors which also have an influence on the evaluation. In order to answer the research questions, we followed the design research methodology. First, we selected our case study, the door wiring harness, which is representative for other harnesses. We documented all changes that occurred during the development process, conducted interviews in order to assess the risk and the effort, and classified the changes according to the variation types, and then analyzed our findings. In the first part of the results, we see what actually changed in this wiring harness. On the top graph, we see the different objects that were changed and that were used to describe the change. In the bottom chart, we see how these objects were changed, and we see that most times existing objects were changed in order to create the next generation of the wiring harness. Here we can see the engineering changes from the previous slide depicted with more information. On the left-hand side, we see the risk of implementation in blue, and on the right-hand side, the effort of implementation in green. In each graph, we see the different types of variation. In the two top graphs, we see the absolute values over all the variation types, and on the bottom part, we see the relative values distributed over the individual variations. We can see from these results that our assumption that the risk is higher and the effort is higher for principal variations to be true. We also see that the attribute variation is more mixed. There's still some high effort and some high risk, but also medium effort and medium risk. We see that for carryover variations, we have a very low risk in a lot of cases, and most cases are low effort or medium effort for the carryover variations as well. So we see that the different variation types actually enable us to give a good prediction about the effort or the risk, which are associated with an engineering change. We discovered some additional factors which also pay into this evaluation. We see that safety relevant features, when they were involved, that tended to be a higher risk. And we see that engineering changes that we evaluated as principal variation, like removing a certain object with a discrete function, that these engineering changes were associated with low risk, so which would even improve our evaluation of the changes. To sum it up, the assumption that all engineering changes can be classified as one of the three variations was confirmed. Second, the variation types allowed a good indication regarding the risk and the effort of the engineering changes, especially with the additional information. Third, the findings can support engineers when they need to quickly assess an engineering change. What should be done in the future? We believe that there is still room for additional analysis of cases in the wiring harness, and also in cases from other systems where it would be interesting if they can confirm our findings. Second, it should also be investigated whether an evaluation on a different level, not only on the object level of the change, would lead to the same results. Third, an automated variation of the engineering changes with the variations would be very interesting. And fourth, also the research into the effect of the variation types of change propagation would be of great value. I hope I could spark your interest for this paper, and I'm looking forward to our discussion. Thank you.
Dear participants of the ZH Design Conference, my name is Dennis Horber and I'm working as a researcher for engineering design at the Friedrich-Alexander-Universität in Germany. On behalf of my co-authors, Professor Sandro Wartzack and Dr. Benjamin Schleich, I present our contribution with the title Identification of Property Change Impacts based on Requirements-Oriented Multi-Criteria Decision Models. In today's engineering design domain, new approaches in the field of digital engineering are needed to address the growing complexity of modern products. In this context, a transformation from document-centric to model-based product development is noticeable, which also applies to multi-criteria decision-making, where a decision model is needed in order to select the best of multiple solutions based on a given set of criteria. If the given criteria are linked to a product's properties, an analysis might result in a diagram like this, where desired target values result from those criteria. The problem is that alternatives don't necessarily meet those targets exactly. Instead, they might be underfulfilled, which leads to a bad ranking of the alternative, or else they might be overfulfilled, which can, for example, lead to excessive use of material. The question arises how to identify necessary changes of the given alternative to better meet the desired property profile. But the problem is that changes cannot only lead to desired impacts, but also to undesired ones. For example, an intended impact on P1 can have desired impacts on P2, but this impact may have an undesired one on another product property. Therefore, it is necessary to identify the change impacts in a decision model in order to improve an alternative. For the model itself, we built on a previous work on requirements-oriented decision-making, where requirement statements are derived into evaluation criteria with a natural language processing approach, and which we extended with a model for requirement relations. Our main goal is to reuse these models in order to compensate the necessary modeling effort. Currently, there is no suitable approach for our intended impact analysis in the state of the art, but there are several promising approaches where we can build on. Therefore, we derived the following two research questions for our contribution. How can requirement relations be used in a multi-criteria decision model to identify and quantify property changes, and how to model those relations? In order to answer these research questions, we analyzed three feasible modeling strategies, where requirements and respectively the evaluation criteria are linked with a product's properties. After the analysis of possible relations, we came to the conclusion that the third type of modeling is necessary for our needs, because only with that approach we can assess the impacts in detail. For the identification of property change impacts, the starting point is then the requirement relation model, which is modeled in a matrix-based approach, but can also be represented in a graph-based manner. This model is then reused and extended by a value function-based approach, where the requirements are linked with the product properties. This link can be identified through characteristics, and in the next step, the relation between the characteristics and properties can be modeled with a value function, which then reflects the decision maker's preferences. By doing so with the different requirements in the decision model, these value function-based relations can be used for a multi-attributive analysis, where directions of improvements can be visually analyzed. But in order to enable the property change analysis, the relations between the different properties are computed and used for the analysis of changes. For the practical application of our proposed approach, we developed a software demonstrator to support the value modeling part. With that, users are enabled to select the corresponding parameters in order to represent their preference regarding the relations. Next, we applied our approach to a use case where the main task was to improve a folding and steering mechanism of an electrified transport vehicle. The results showed that there are significant dependencies between some requirements, which lead to undesired impacts when trying to improve the alternatives. This applies, for example, when changing characteristics which are linked to requirements 9, bore tilt angle, as well as requirement 10, maximum control rod deflection. In case they are negatively affected, the product property regarding its safety is impacted accordingly and in an undesired manner, which leads to a worse ranking of the alternative and is therefore undesired. Now I want to briefly conclude and discuss our contribution. With our approach, product developers are enabled to assess impacts of desired property changes and identify negatively impacted properties. Regarding applicability, our developed software demonstrator supports the modeling of the parameterization of value functions to meet the preferences. But this aspect has to be investigated in a more extensive study in future. With our approach, we achieved our goal to reuse the requirements and criteria model, and therefore the initial modeling effort is reduced. But there are limitations which have to be focused on within further research. For example, the required modeling effort has a strong dependency to the number of included model elements. However, this can be reduced when the model already exists from a previous product generation and only has to be adapted. Also, a consistent value definition is mandatory throughout the approach, and the relation modeling itself underlies uncertainty. But there is a great research potential to extend the existing natural language processing approach to derive characteristics from requirement statements and already suggest possible value functions.
Hello and welcome to the presentation of our research paper titled Concept of a Multi-Agent System for Optimized and Automated Engineering Change Implementation. My name is Ognjen Radisic-Aberger and I will guide you through today's presentation. First, before we dive into the multi-agent system, I present some key definitions. Our research deals with agents, autonomous entities which independently act based on the environment they perceive, all in the context of engineering change. ECs are changes to products caused by a trigger. Usually, the ECs are handled according to the EC process seen on the right. Our focus is on the engineering change implementation, the fifth step after approval. The goal is to implement ECs as efficient as possible, and the key challenges include capacity constraints and high communication effort. Especially in complex industries like the automotive industry, the implementation challenges increase due to digitalization of products and distributed production networks. As such, associates find themselves in a situation where a multitude of ECs have to be steered across the complex networks of suppliers and producers. One could compare engineering change implementation with air traffic control, but without the appropriate systems. And I think everybody can imagine the chaos which ensues in the skies if air traffic is not appropriately controlled. Similarly, our multi-agent system is envisioned as an automated steering and control system, leading to the research question, what would be the design requirements and principles for such an automated ACI system? From challenges observed and literature reviewed, we have derived 4 business needs. Business need 1, namely, is the task of the material planner to optimize the effectivity date. Business need 2 is to predict whether the EC can be implemented on this particular date and the ramifications on other KPIs. Once the results from business need 1 and 2 are available, an EC schedule is to be derived, resulting in business need 3. Finally, the EC process needs to be monitored and controlled, which is currently done by the EC coordinator. From these 4 needs, we devised 4 agents, one for each of the business needs. Namely, the optimizer agent, the predictor agent, the negotiator agent, and the supervisor agent. Each agent on their own would already help optimizing the ECI phase. However, we suggest going further and automating the EC implementation to a certain degree. In order to do so, we present the concept of a multi-agent system, where the 4 agents collaborate. As an example, from a shared database, an EC configuration is derived and given to the negotiator agent. It is sent to the agent and requests calculations from the optimizer, and once an optimal date is received, it does the same to the predictor agent. Negotiating between the result of these 2 agents at the EC is scheduled. This is where a supervisor comes into play. He monitors the process, feedbacks any deviations to the negotiator, and presents the current status to the organization. Once the EC is implemented, this result is then added to the database for the system to learn for the future. However, we do point out that this is a concept, and further research is needed. To realize the multi-agent system, all 4 agents need developing. To do so, we have presented the tasks, performance measures, data requirements, research needs, and agent logic of every agent in our research paper. However, today we are going to focus on the tasks and research needs, and for the others, we refer to our paper. For the optimizer, calculating the effectivity date dynamically results in a research need on meta-heuristics. Currently, effectivity dates are calculated by linear programming, which is not suited for dynamic calculations of discrete, nonlinear input data coming from ERP systems. Similarly, the task of the predictor to anticipate whether an EC will be implemented as planned requires research on which data to actually use and which machine learning algorithms, probably supervised machine learning algorithms, are best suited for EC prediction. The negotiator agent, as the brain of the multi-agent system, is tasked with scheduling and coordinating the ECs. Research should focus on how to improve the scheduling abilities over time, and thus we suggest researching reinforcement learning for autonomous improvement of the rule set. Supervisor agent, as the last one, is a simple trigger agent. However, registering any deviations and providing the feedback to the organization and the multi-agent system, the agents should focus on development of an ECM-specific state-of-the-art UI/UX system for monitoring ECs and providing feedback as good as possible to the stakeholders of the company. In conclusion, we have presented the concept of a multi-agent system for optimized and automated engineering change implementation. The main driver for this research is the resource intensiveness of EC implementation in complex industries and capacity not being sufficient to adequately handle all changes. Out of literature, 4 challenges were translated into 4 business needs, namely optimizing effectivity dates, predict implementation impact, schedule ECs, and feedback to the organization on the current status of the EC process. As a solution proposal, we have presented a multi-agent system for automated engineering change implementation. It consists of 4 agents, one for each of the business needs, and basic requirements and research needs have been provisioned for each of the agent. As a limitation to our research, we point out that EC is a complex process and that most costs are already defined in earlier process stages. Additionally, whenever dealing with AI, data availability and quality are a key issue when employing machine learning. As an outlook, each of the agents is currently in development. It will be tested and soon deployed in a real-world production environment once the agents are ready to go. Thank you for your attention, and I'm happy to answer any of your questions.
Cool. Okay, yeah, fantastic. Thank you very much for your presentations there. They're brilliant, really insightful. I've posted a couple of questions myself in chat, so please feel free, for the audience to post those in chat as well. So I guess without further ado, we might go for those. I thought I'd post those so you could prime yourself with some answers rather than me kind of, surprising you with them. So yeah, I thought we could start with Raquel there. I just wanted to kind of bit more of a clarification, Raquel, on on the nature of your ECs, have they been? Have you captured that? Are the ECs capture where you've got the same components, maybe in multiple ECs? Do you group those together? You mentioned batching in those ECs. So, is this the case where the change has already happened and it's actually just implementing it onto the car, or are you focused on actually how do we combine all these ECs and then, actually generating the new components to then put on the car? So I don't know. I guess it's just about sequencing and order, if that makes sense.
Yeah, thanks for the question. Actually, the focus of the paper is on the implementation phase. So the decision of what the best change is a step before. It has already been approved, and it's also been assigned all the dependencies. So this is something that comes as an input for the implementation phase, but it is of course something that has to be considered in the implementation, because if two changes depend on one another or depend on the same part, they have to be implemented at the same time. So this is why one of the KPIs considered in the quality part is this batch adherence. So for some changes, it's an absolute requirement. Okay, this has to be implemented on this date because this is the planned date where all the changes that have to do with this part of the car will be implemented. So in this sense, like if a change comes and the method sees okay, it has dependencies, then it doesn't go into the optimization. It goes directly to this planned implementation date. And it is this is why it's actually one of the future lines of further research to maybe think, okay, this method is for individual changes. Where you say, okay, this individual change, when can it be best implemented? If it has dependencies, then it goes directly to this predefined date. But maybe to see, okay, is there a way to adapt the method for groups of changes? That's something that has not been yet done and would definitely be very interesting and has a potential for optimization and cost saving, definitely.
Fantastic. Yeah, thanks for that clarification. Yeah, that's what I thought it was the case. Yeah, I just wanted to make sure where your system boundary was. And apologies for people who haven't maybe seen the paper yet and stuff. I was looking at figure 6 on that earlier whilst I was reading your papers, and there's a lot of cycling between two values. I don't know, I see you probably have to pull it out yourself at the site. I was just wondering if you could just clarify what that cycling was. That's it, between like two sets of options.
Yes, so you're talking about the different scenarios, right? Yeah, so this is something I actually did not mention on the presentation due to time constraints. So for those who haven't read the paper, it's about, in some cases, when you apply a method, the result can be, okay, the optimal implementation. Sometimes like the scrapping costs are so high and so relevant compared to other costs that basically when the scrapping costs reach a minimum, the method will say implement on that date. So in this point, we introduced like a new decision variable that could be, okay, what if we stop asking for delivery parts maybe a month earlier, then the parts will finish and then we will have an optimum also earlier. So it's about like playing with this, when do we stop asking for deliveries? So the idea here, like the main source of savings is actually to introduce this possibility. And once it's introduced, you can also decide, okay, what day is better. But these are like minor savings. Like within, if you see on the paper, it's like 100 euros difference. So it's not a big one. So it would be like, okay, within this canceling a delivery, there are dates which are better than others, and this has also been like researched. But yeah, the main maybe the question goes in this direction, like, is the saving really relevant if it's just a few hundreds of euros? To this point, I also want to say, like, these individual changes, you don't save a lot of money with each, but it has to be taken into account that in the automotive industry there are tens of thousands of changes per year, so it's this multiplicator effect.
So that's why, sometimes you save 10 euros, but it's this multiplying effect that makes it then interesting for the industry. I don't know if you answered the question.
No, absolutely. No, that was fantastic. And I kind of did prime that because I thought that was in the paper, but you didn't discuss it in the presentation. So I thought I'd give you an opportunity to discuss it a bit. So yeah, that's fantastic. And kind of leads nicely on to the second presentation there, Moritz. Again, I didn't realise, like, I was fascinated by the values of the change. I've never really appreciated the concept of how many changes are happening per month, per year across the automotive industry. And I had one, again, a kind of follow-up question with from Raquel's about that, how you're managing dependencies between ECs, who you're coordinating change. And if you've got any comments on that.
Yeah, so that's also one of the very relevant questions, to actually look which changes affect each other. And it's quite hard to tell because we only looked at like one part of the wiring harness. We looked at it over the whole development process. So we saw, for example, that some parts were changed and then changed back like a few development generations later because something was discovered that did not work out well. So there's this kind of connection, but sometimes changes just occur in the same wiring harness but have no interaction whatsoever. So it's quite difficult to actually assess, or to just from looking at it, at a change, if it really has an impact on another change. And that's why we actually chose this approach to investigate it a bit more. And so there's a tendency that if like a part of a function or like a function relevant part is changed, that also other parts are affected. In comparison to just like slight alteration, maybe to a part which alters the fixation concept of the wiring harness. So when it's just a small alteration, of course, the effects and the propagation is not so big. But it's also like, as Raquel also said in her research, like looking at what changes actually affect other changes is still like very interesting. And it's very hard to not only predict it, that there's a likelihood, but to actually say this will definitely affect another part.
Absolutely, yeah, and I think that's the key thing with these kind of tools and methods, is be able to play out those scenarios, so you can investigate and experiment and say, what's the likelihood, and maybe do like say statistical modelling on top of that. That kind of follows on as like to have the additional follow on that change, because you talk about let's say managing the risk of changes, and I was wondering if you can play out scenarios. So I put one in there as the idea that yes, sometimes you might want to avoid high risk changes, but sometimes you have to do them. But equally, can you play out scenarios where maybe you can go, okay, yeah, this is a high risk change, but by performing that high risk change, it would reward you with a lot of low risk changes in the future. So you're looking more of a systems level of risk, as it were, rather than just like, risk at any one point, any one change. I don't know if you've explored that, or that's your intention in the future.
So it came up in the interviews that there are certain things that affect like the risk which is connected. So more parties are involved. If it's not only the supplier that it's involved, but like the tier 2 and tier 3 suppliers. So like a chain of suppliers which are involved. So this means that there can actually be a change if they were involved quite early on, that they don't have to think up everything new from the beginning. It makes sense to, let's say, include a concept already, which would increase the risk of implementing it or changing something early on. But then at least those parties are involved and they're actually like thinking about it. So this would be an approach, but it's wasn't like the main focus in that sense.
Yeah, that's great, fantastic. Thanks for your comments there. So if I go on to Dennis, if I may. I've got a question from the audience there. So sometimes engineers build in excesses or over designs when designing products, sometimes to absorb changes. So have you considered such a scenario where there may be no impact because the change actually got absorbed by the design? It was designed in that it could accommodate that change, as it were.
So first of all, thank you very much for the question. So basically in our case study, where it was improvement of the steering and the folding mechanism of the device, we had no such design issue where over design was implemented to absorb changes. But I can imagine that because the designer has to model those relations in the requirement relation matrix. So when there are relations not modeled to represent the over design to absorb the changes, then this might be a point that a designer could have in his own hands, and but has to decide that the designer does not want to have a relation in this exact spot. So currently it's up to the designer, and but I think that would be possible to implement. Yes.
Mm-hmm. Cool. Thank you, Dennis. Yes, hopefully that's answered your question there. The so I kind of, if I was going to follow on with that, so you mentioned that you've been using it in anger to monitor and affect change and analyze the changes post, like say, a product being developed. So I thought, maybe we could be potentially proactive with your method, and you do it as you design. So as the design's evolving, and you can almost go, okay, let's evaluate this design concept for its potential for change. So you could use your tool to go, actually, this could, but following on from the previous question, it could accommodate, this is one could accommodate change more so than a concept A or concept B. You can compare them. Have you got any thoughts on using it in that fashion?
Yes, I think it's a very good point that you're mentioning. So it would be very valuable to extend the approach to use it like this. I think it's also highly dependent on when or which design situation or decision situation you're referring to. If you're very early in the product development stages, might be hard because there might be very much that there might be a high uncertainty in terms of the relations and the characteristics and properties. But when you go further in the development, that's I think very a good point to address and approach and use the approach in a fashion like you mentioned, the downstream process where you identify the changes. But it's currently, like I said before, up to the designer to assess whether a change is easy or not, like you're mentioning. Right.
Yeah, absolutely. Yeah, and I think that's it. It could be, like you say, how you use these tools, and then where in the process you might start off with some kind of more heuristics at the early stage, where you go by some principles, by minimizing parts and all that kind of typical design for manufacture, but you kind of design for change principles. And then as you start getting to more detailed design, you can then start deploying your methodologies that you present here today, where you can go, right, actually we could play out some change scenarios on our concept as it is now to see whether it would be malleable or can accommodate changes in the future. So thank you for your points there. Then last but not least, Ogi, presenter for there. I thought again, it's kind of this is a field that I'm really interested in, agent-based modeling and approaches. So it's really good to see it being used or considered in engineering change management. So I was this first one was kind of a point of clarification. I wasn't sure whether the agents, once the EC's been scheduled, can they affect change and reschedule as new ECs come in, or do they just shift it if there's a precedence? What level of rescheduling is possible with your agent-based system at the moment?
So thanks for that, to clarify that. So our agent-based approach, it could do it. So basically, if you look at the logic of the negotiator agent, it basically has this loop where it permanently checks with whether the prediction and calculations still deliver good KPI results. And if they don't, basically they request a recalculation and effectively could do a rescheduling. However, so this was 15th of November when we handed that in. Since then, the research has progressed, and we do currently say we don't recommend this. Mainly, unless it's obviously clear that there is no chance it's going to implement. But as long as there is a chance to implement, we would now suggest stay true to the effectivity date, and just reduce the last call-off. So what Raquel has said, switch the numbers of the call-offs, maybe shift something there. The main reason why is we have encountered ECs where up to 50 components are changed at once. From 50 suppliers. So if I have to manage 50 suppliers, again, just to shift 1 or 2 days, the complexity of this is way higher and way more intensive than what I could save by actually shifting just this 1 day. So that's why we would currently not suggest to reschedule once an EC is scheduled.
Yeah. So yeah, there's a very high penalty then for that's it.
Exactly.
So you need to get that scheduling right really first time in a way, don't you? That's it.
Yeah.
Okay, interesting. Yeah, I guess you said like the research has moved on since you've submitted this paper. So I was wondering if you actually come to do some like you say agent-based modeling through the likes of AnyLogic or some agent-based modeling software. Is that where you're taking it so you can simulate how this process these agents can coordinate a profile of engineering change?
So no, our research is currently focusing on which algorithms are actually best for that, for the core responsibilities of each agent. So for instance, this optimization algorithm or optimization agent has meta heuristic at its core. And currently we are running research which of the various meta heuristics is actually best. And currently it indicates that, for instance, ant colony is most reliable, but doesn't deliver the best results. So that's a trade-off that we're currently looking into. And same goes for the predictor. So we are looking into which algorithms are best used for prediction, and we're less focused on the agents themselves.
Okay, cool. Okay, and then just one final one then for yourself is have you did you ever consider the engineering change being an agent itself? And it's discussing and debating whether I should be scheduled or not.
At some point it came up, but we haven't thought this to the end, because we said currently we are trying to basically use as much infrastructure as possible as what's already there.
Okay, yeah.
And that means switching to where the EC itself is the agent. Interesting question. We could actually discuss it further, yeah.
Yeah, absolutely. Happy to follow up. Yeah, sorry, this is probably a bit of a primer and a shameless plug, but we're doing some work on brokering additive manufacturing machines, where we've got the machines themselves as agents and the jobs that are coming into the workshop as agents. So they go and barter and broker, jobs between them, each other. So they bid for work effectively. It may not work for this context necessarily because, like you say, the penalty of being rescheduled or moved from another machine would be so high in your context, rather than with an additive manufacturing machine moving from one machine to another. There's not that penalty. But happy to follow up on those. I think that's it. You never know. It might be an interesting way to see if it might function for you. So just checking chats. I'll wait for some potentially more questions. But I thought I'll just open up to all of you, because I think that, like you say, there's a really nice set of approaches that ultimately are looking to achieve that same end goal of optimizing the change process and the sequence of events and the sequence of change. I was wondering if you might have some reflection. This is probably pretty hard to do right now, but how would your systems sit alongside one another, or do you feel that a business would have to pick one or the other, or do they do them in a sequence? Do you see some alignment there, or is it maybe product based and certain approaches are more favorable for different types of products? So very open-ended question there maybe, but how do you see your approaches sitting with one another and working together? Who should I nominate to go first?
Maybe I can start. So one thing first. So Raquel's work is already integrated in the multi-agent system, because it was she was working with me on the same topic. And so basically, yeah, so what Raquel started with her database method is basically the core of the optimization agent. And also regarding what Moritz did, so basically predicting the effort, predicting the impact and the risk of changes, that's also something that could be re-implemented into this predictor agent. So it doesn't have to be machine learning based. It could be based, as Moritz did, by pure statistics. Yeah. So
yeah, so almost like say some of the, Dennis and Moritz's work, yours could be incorporated in those types of agents. Yeah. Yours is like the overall framework of how, each of those could provide a different lens on whether to affect the change or not, or when to schedule it. And ultimately it comes down to the coordinator agent to take all that information on board and then make that final decision.
Exactly.
Yeah. So any thoughts from Moritz or Dennis on that at all? Or just do you see that?
Yeah, I think this could actually work quite well. And there's also like a slightly different approach, because Raquel and Ognjen are more looking on how the connections also to like other domains, which is also relevant. And what I try to do is like look a bit more on like the technical side of the change, because like often like looking at like the reason for the change, or like the impact, or all these issues have been discussed quite well, but there's still a lot to do. But I think that also looking at what actually happens is it's quite hard to find in the data. So that's why I try to get around there to actually get a bit more information. So I think that's interesting. And also what Dennis is doing, I think that's also like very interesting to actually look at the requirements, like starting a lot earlier in this process to also optimize the process at this point.
Absolutely. Dennis, any thoughts? Or?
So basically I agree on that. So I have nothing more to add actually. Yeah.
Fantastic. Yeah, I can almost imagine that you say we're almost with these in each approaches, like you say, could be featured as a separate agent in this multi-agent system, and you're almost making this kind of design meeting where these agents are coming together saying that this is what I feel that the schedule should be like based on risk, this is how I should feel based on the requirements, this is how it should be based on based on features. So it's like almost they'll go to a design meeting, and where that coordinator has to then duke it out to say, okay, how do we make the best compromise, or are they all in agreement, which then makes it really nice and simple, and we'll just go for that schedule. So yeah, if we make that, could be an interesting thing maybe at some point to see if you could bring those together to see if we could understand how they could have a meeting of the minds, as it were, and you can weigh up the pros and cons from all these different perspectives. Oh, so I'm afraid that I've got no more questions in the chat, and I feel like we've had a nice discussion. I appreciate that it's a bit later in the day. I don't know if there's any other last thoughts from yourselves, or we could say maybe potentially Philip, if that's okay, to call it a little early.
Yes, it's okay. If there are no questions, we can end it early.
Okay. Have you any other last remaining thoughts, presenters? Or that's you, Philip.
Yeah, that's just me. Just a reminder that after this session, in 20 minutes, there is a social gathering at Gathertown. So join us for some fun games and talk with other colleagues and networking.
Fantastic. I think that's probably good then. That's probably a good time. So we can all have a bit of a comfort break, get away from the screens for a minute, and then we can come back to reset the eyes a little bit, and then meet up at the gathering. Awesome. So last thing I'll say is fantastic. Thank you very much for the presenters, and congratulations to Raquel and Dennis for your reviewers' favourites. And we will see you at the gathering. Oh, cool.
All right.
Bye, everybody.
Thank you, everybody. Bye-bye.
Bye.
Bye.
Okay. Thank you, James, for sharing this session. I think everything went well.
No problems at all. No
Okay.
worries. Thank you, Philip. Thank you.
Thank you. See you in Gathertown. Bye.
Bye-bye, everybody.
Bye.